Hello. Good afternoon to everybody, or good morning, depending on the time zone. I hope you can hear me now, because it's the first time I've done a webinar like this. Alright. You should see the title. We'll just wait for a couple minutes in case somebody is slightly late, but we'll get started very, very quickly with the updates. It's 3:01 here in Spain, and in just a few seconds I'll get started with the webinar. Welcome to everybody. I can see a few people joining already. Thanks for showing up for this webinar. Hello. All right, so I think we'll get started now. Thanks for the feedback, Emmanuel. Very nice to see you. Okay, so we'll get started. My name is Pablo Callejo. I am the manager of the motion capture division at STT. I'm sure some of you are users of our systems, so we already know each other. Thank you for joining us today. I'll try to describe very briefly some of the highlights, some of the main enhancements, new features in the latest 3DMA version, which was released a couple of weeks ago. There are many enhancements and many new features, so I made a list of what I think are the most relevant ones, and I'll be more than happy to answer any questions afterwards. I'll try to give my best answers, and if needed, I have some of my colleagues are joining me as well, so we can, between them and myself, we can probably answer you about anything. So I'll be sharing the desktop and showing you some of the new features straight away. Please don't hesitate to make any questions while I speak. There's someone else helping me out with the answers. All right, so I'll be following roughly a few guidelines, a list of topics, which I decided to sort like this. First, I'll be talking about the export, import options and syncing with third-party devices. Then I'll mention some of the enhancements in the database related to how searches are done in the databases, items sorted out, and a few other things. And on the second half of the session, I'll be talking about a few protocols, Gait analysis, running analysis, cycling analysis, and more specifically about some of the new aspects or new features that have been included lately. All right, so let's get started. I'll just show you. I'll start running one of the 3DMA applications. As you all know very well, 3DMA is a family, it's a suite of products. They all share a unique motion capture engine and kinematics module, but we can effectively change the interface to provide different analysis protocols. So I'll be running clinical 3DMA to explain some of the new features, but these features are common to most of the other products. All right, very good. So let's talk a little bit about export and import options. There are a few elements in here. I'll open just a random capture over here. You'll notice one new icon over here, which I'll explain in a second, and then two old icons, import data and export data. if you click on export data, you'll notice a few new options in here. So one of them is, for instance, the export option. The export to C3D. C3D is a very well-known format. It's almost a standard in biomechanics, as most of you know, and has been used widely since the 80s and 90s to store raw data together with the force plate data and third-party data, generally speaking. So now it's very easy from 3DMA to export C3D file just by clicking in here and creating the file. Likewise, you can easily import a C3D. I'll do that in a second. So if you go to import, then you can have a C3D file imported into your 3DMA software. Now, the way this is done is through a new dialog. This dialog presents on the first column the markers that are found in the file, in the C3D file, and then a list of a list of markers found in the file, and then a list of markers found on the protocol that you have selected up there. In this case, because I know the selected file comes from a gait analysis, which was performed with another motion capture system, and I know it was performed with a Helen-Hayes configuration, I'll just select the Helen-Hayes model in here, gait analysis, Helen-Hayes, and these two columns allow me to do a matching between both lists so that I can import markers efficiently. I could link one by one, or because they are sharing the same names in this case, I can just automatically perform this linking. I should, on a final step, I should just make sure that I am using the correct units. In this particular case, if I'm not mistaken, the measurement units in the original file were millimeters, and the vertical axis was the Z. As you click OK, the tracking data will be loading into your scene exactly. And since I already selected a protocol, Helen-Hayes protocol in this case, the system already tried to auto-calculate gait events, which it successfully did in this case. So if I go here, yeah, I can see how the events were correctly generated. And then as well as some of the parameters and biomechanical curves. Then once the recording is inside 3DMA, I can treat it like any other motion capture. What this means is that 3DMA is now more open to integrations and import from third-party motion capture solutions. I could also import data from much more raw formats such as TRCs or TSVs, which are basically marker trajectories on an ASCII file. So I don't need to import data through a C3D file only. Some of the other export options, let me just, I'll just skip this one. I mentioned one of the export options, the export to C3D file. There's another one here, which is create video from 3D view. Now what this does is it creates a video, an MP4 video, taking the 3D scene as a feed. Now this used to be available in the previous versions, but it was a very heavy AVI file, and now it's a much lighter file. It's an MP4 format. Now you can also export the video feed from any recording. This particular capture which I imported doesn't have any video feed, any video camera, but I could now export this video feed into an MP4 file. This is something that some customers have been asking for quite some time, and it's finally here. So now you can create a separate video if you have recorded it through 3DMA. Great, let's jump into the next set of topics, which are here. I think I just realized that my video feed is hiding some of the elements, so I'll just put it here if you don't mind. Very good. Alright. I mentioned that we can export and import C3D files. We can also export events. One of the other export options is the export event. This is a pretty simple option that generates a text file, an ASCII file with a list of event names and the timestamp in which that event took place. One of the other major enhancements in 3DMA has to do with, I want to save this one, with the force plate integration. So now we can integrate up to 8 force plates into 3DMA. That's quite powerful, and even though not many labs actually have 8 force plates, but it is quite typical for many labs to have 1 or 2 plates. If you take a look at how this integration works, well, it's pretty straightforward. So in this particular case, there's a patient walking through the 4 force plates, and you have, as a real-time feed, you can take a look at the force vector on each of the force plates. This force vector is actually applied on the point where the force is taking place, but this depends on the force plate model. Not all models can provide the point of application for the force. All right. So we can take a look to the force vector as well as the magnitude over time. And of course, we can easily take a look at these graphs over time as well. Since we have 4 force plates in this case, well, I'll just show the vertical forces for these force plates over time. I want to show FZ for all of them. In this case, the guy or the person here seems to go back and forth. Yeah, it's actually going out and then turning around and going back to the scene, to the force plates. You will observe that by the end of the capture volume there is less visibility of markers. That's why some of them get a little bit messed up, but that's not a problem because we can easily create events, as you can see on the plots, to focus the analysis on an interval that is meaningful and interesting. Well, all this data can be exported, but I'm sure many of you, or if not all, are you familiar with that? Okay, of course these parameters are, these new graphs are exported into the report. So if I wanted to generate a report, in this case it's gait over ground. That's important because it affects some of the parameters. And I can choose whether I want to include each platforms plus the average, the sum of all the force plate data, and if I want to add also the force data per gait cycle, which is also very interesting. The report is one of these reports over here. I believe this one is already being generated with a force plate. Yeah, like you can see here. Very good. Let's move on. I'd like to explain, I forgot to mention that this protocol, Helen Hayes, is not the only one that can be integrated with force plate. The force plates can be used with any protocol. Also, if you're using a full body model or a Rizzoli protocol, like for example, they have a few samples here, Rizzoli or Leardini marker set, we get the exact same behavior. So 3DMA doesn't care which protocol, analysis protocol you are using the platforms with. Great, let's move on to a second section or group of enhancements. In this case, I want to mention a couple of new features related with the database. Now, the searching capabilities in the website have been improved a lot now, so it's easier to look for for things inside, especially if you have a lot of patients, right? So if I want to perform an advanced search, I just enable this option over here, and I get two fields here, notes and protocol. Now this allows me to search by words which I can type here. For example, I remember a patient who was injured, and well, I can remember in this case a keyword like injury, for example, and I get the filtering result, the filtered result showing the patient, or the capture rather, with that word inside. Or I could, for example, look for a specific protocol, Helen Hayes, and then yeah, all the Helen Hayes protocols or captures are within this particular patient in this case. Then one other interesting feature is that we can now sort captures by the date of recording, so by the last recording. This is interesting if you want to look at patients over a recent period of time, for example, or on the contrary, if you wanted to look for very old patients or very old recordings. Now it's easier to sort them out by clicking on this column. One other thing that has been added is support for PDF documents. So now you can store external documents inside the database. As you can see here, this is just an example, and they can be opened using the predefined tool. In this case, I'm using Chrome. All of this makes certain practical things a little bit easier. Great. Let us focus a little bit more on protocols now. So those were some general aspects: import, export, syncing, database. Let us focus on some of the analysis protocols now. Let me open one of these sample gait analysis. I'll pick one that has a very long hallway. Very good. Now, one first thing which I want to mention before I forget is that the report for gait analysis has gotten some remodeling on the first page, so it's now even more visual and even more attractive and useful. So the first page always presented a stride analysis, but it's now being presented in this way, where you can see the initial contacts and toe off with the timings in proper graphic elements. And there is also a little bit more of info on the step on the stride analysis, like for example the heel height. This is an average. This is the maximum. Sorry. Overall, it's a very attractive first page report. Just a reminder that whenever you are doing a gait analysis, you should be careful and always fill in these parameters, these anthropometry parameters or measurements, just to be sure that all the calculations are right. Okay, and if there is any doubt on what these mean, there is a very detailed documentation on which by just clicking on that icon. All right, this helps the algorithms calculate in a much more precise way the different biomechanical parameters. Okay, having said that, I wanted to mention one or two things that come up in the stride selection dialog. So once you have done a gait analysis, as you all know, you can click on this new tool, which allows you to remove, to filter out some of the curves if they are way off, or if there was a tracking failure or whatever reason. Now this list is offering all the biomechanical parameters, I mean all the curves for all the joints, and it is now very easy to export all these data sets per gait cycle, which is something interesting for researchers. What this does is it will create a lot of CSV files, one per curve per side, containing all the available or rather all the enabled curves over the gait cycle from 0 to 100. So you will end up in this case with 12 or 13 curves multiplied by 2, that's the number of CSV files, and each file containing as many columns as curves in here. I don't want to do it because it shows a lot of files and it's a little bit messy. Anthopometry, filtering, gait analysis, data export. Okay, now I'll switch to another application. Okay, I started with clinical 3DMA, but I want to continue with sports 3DMA, just to show you some of the new features on sports protocols. Very good, here we are. Here we are. I'll grab one of the existing sample captures over here. Which one did I like? I like this one, for example. This is a subject running at 12 kilometers per hour on a treadmill. We're using the full body running analysis protocol, which is based on the Helen Hayes configuration for the lower limbs, plus some new markers on the upper limbs. Now, you can see this fellow running. One of the new things that you'll notice is that we've added a treadmill representation, which makes the whole scene a little bit more friendly. And you'll notice that the treadmill is changing colors, and that's in relation to the events. So whenever there's a foot strike, the corresponding half of the treadmill will be colored in either red or blue. That's one thing. If we generate a report, in this case, I have to select whether it is running over ground or treadmill. In this case, it is obviously running on treadmill, as I mentioned. The report here has also been enhanced a little bit further. There are a few parameters which we were not presenting before, more specifically on the pelvis. So where the pelvic data is a little bit more comprehensive right now. And also we have added a leg stiffness parameter. Now, leg stiffness is something that can be very relevant for athletes, especially in injury prevention, and also for the high-end or professional athletes. And it used to be quite hard to measure unless you had a force plate or instrumented treadmill. Now, there are ways to make a very good estimate of the leg stiffness, and that's based on some certain studies and bibliography. Actually, that's the document I was looking at here. Now, based on certain kinematic calculations and very, let's say, easy to handle measurements, we can have an estimate of the elastic constant of each of the legs, and like this paper shows, it's the estimation is really quite good, and it's basically based on these four measurements over here: body mass, forward velocity, leg length, flight time, and contact time. If you're interested, we can share of course the references for this. Very good. I'll move on a little bit forward to present a new protocol that we've introduced in Sports 3DMA. It is the less score protocol. The less score has to do with this other paper over here precisely. Is a way of assessing the injury risk for lower limbs, and it is based on a very specific exercise that involves forward jump and vertical jump combined I'll open sample recording. Here it is. So we're using a modified version of Helen Hayes with some additional markers, as you can see, and the athlete, or well, the patient actually, is asked to stand on a box that is 30 centimeters high, and it has to jump up to a certain position, and the distance up to which he has to jump is the 50% of the inter-shoulder distance, if I remember correctly. Now, and the motion goes as you can see here, so it jumps forward and then vertically. Now, this is backed by many studies. This protocol doesn't just monitor biomechanics over time. It creates a sum of scores and provides an overall score, and the overall score gives a good idea of the risks of certain lower limb injuries, such as ACL injuries, for example, anterior cruciate ligament injury risks. And actually, yeah, I think I lost the paper, but again, let's take a look to what we have here. So there is, if we take a look to the documentation on the LES protocol, this is the documentation provided for each of the analysis protocol. All right, here we have the description, how the capture is set up, which is quite easy actually, and the marker placement. Good. And then also we can take a look at the interpretation or the explanation of the different parameters. Landing assessment with LES protocol, description of numerical parameters. Now, this is a very detailed description of what each of those individual scores is measuring, and then a reminder on how the final score works. All right, so the lower the score, the better. As we explain here, according to literature, a good landing will not be over 5 points in the LES score. All right. Let me just move on. Of course, there is a report. I forgot to mention that, but like any other protocol, there is a report available for the users. Okay, let's move on to some of the new features included with cycling 3DMA or with the bike fitting analysis, generally speaking. I opened one of the sample recordings. In this case, it's a TT position analysis, time trial. And first I want to mention that we added the possibility of including different crank length for left and right sides. Okay, this is not, I mean, this happens sometimes. We need to type, we need to use a different length, and up to now it wasn't possible, but now it is. Also, yeah, since I was here, now you can add a different tibial tuberosity for left and right, which makes a lot of sense, because if we remember how KOPs is calculated, KOPs can and will actually be different for each of the legs, for each of the knees, so it makes sense to treat each of the knees individually, not as a whole. Now, there are a couple of new and very interesting curves in cycling 3DMA, or in the bike fitting protocol, which is also included in sports 3DMA. So flexion speeds and accelerations have been included. Some people, mostly in the research field, but also also people working in bike fitting are interested in the speeds over time. All right, that's important. That's the angular speed. We have also included the marker speeds. These are linear speeds. So if I show here left foot and right foot, these are the speeds over time for the markers on the front markers of the foot. And finally, we also included what we call, and also the literature calls, coordination curves. Coordination curves are a combination of flexions from two different joints. So instead of showing a flexion over time or any angle over time, we're showing here the one angle from one joint in relation to another angle from another joint. When I'm saying angles in general, well, this is typically used with flexion angles. So these curves are comparing hip angle versus knee angle, and then knee angle versus ankle angle, and then the ankle versus the hips. Now this is interesting because there are some studies, and that's the paper that I was actually looking at before. There are some studies showing, this is what I wanted to explain. If you just look at angles over time, it might be difficult to make some conclusions on technique and efficiency. But if you combine two curves like we just explained, some of the differences between novice cyclists and elite cyclists pop up very, very obviously. As you can see here, these are the curves relating dorsiflexion or plantar flexion, in other words, ankle flexion, relating that with the hip flexion. You can see the difference between the elite cyclists and the novice cyclists. Now, these all make sense because the lower limbs are not just one individual joint or a set of joints working individually. They are all working together, so it's a complex mechanism, and there are compensations going on each leg on every cycle. And to understand how the full leg works and whether this combined operation is coordinated or not can be very insightful, especially for high-level athletes and scientists. Very good. There are a few other improvements on the, of course, there are a ton of enhancements on the reports, on the numerics dashboard in here, and also on the plots in many protocols. But I think I highlighted the key enhancements. And of course, we have many new things coming up. For example, in terms of protocol, there are a few other protocols in the making. So we're working on the kayaking and rowing protocol. We have ideas for a much more powerful full body analysis protocol. So like an older, broader, or a more powerful version than the standard 19 protocol. We have ideas for new protocols in bike fitting to allow users to focus to perform an analysis on a specific body joint instead of going for the entire body. For example, if you're interested in a quick check of the ankles or the saddles, sorry, the cleats, can be interesting to do a quick analysis on the foot, on the feet, and the ankles, and not necessarily on the entire body, for example. And I think I mentioned all the points that I wanted to. I'll now switch to camera view. Not sure if there are questions here. Let me take a look. Very good. I think we are reaching the end of the topics that we prepared for the presentation. If you have any questions, I'll be more than happy to address them. It can be also any other time, so you don't need to go online and to post a question now. You can do that later, of course. And as you can imagine, yeah, we're from STT, we're working from home, but keeping up the work very intensely. So development goes on, and also the technical support. So if there is anything that you would like to discuss, or to both from the technical point of view or commercial point of view, we will be more than happy to help you out. If you have questions on any of the aspects that I just mentioned, please go ahead. And well, and I wish you and your close ones safe time through this coronavirus crisis, which is quite annoying and of course dangerous for some people. We're looking forward to okay, so here's a very practical question which I forgot to address: how to download the software. Very good. So it is as simple as going to the website. Let me just I'll share the screen again, just a second. So you can just go to the website, Motion Analysis Solutions, Downloads, Software Downloads. And then you can download the specific packets that you already have, the newest version, in this case 2020.0. And there's a changelog down here, which is useful if you want to take a look to other features that I forgot to mention, or simply because there was not enough time. Improvements and a lot of bug fixes and so on. And of course, I didn't say that, but if you have ideas for new protocols, don't hesitate to share them with us. One more thing on the download of the software. The license, your license should also be updated, but that's automatic, so it should already be updated. It means that you can just download the software, run the software, and if there is a need to update the license, that will happen automatically, so you don't need to do anything about that. And well, I think that's all for me. Thank you very much for your attention. It's a pity that I don't get feedback from you guys, but it was nice talking about 3DMA this afternoon. I wish you all the best. Have a nice day. Enjoy.